Lesson 8, radioactive decay and half-life. So half-life is the idea of the object reducing its total particles in half and how much time that would take. So a half-life period is the expected time for any sample of nuclei to decay to half its original number of nuclei. For example, carbon-14 has a half-life of 5,700 years. Feel free to read the probability stuff above. Not really necessary at this point. So you'll see that we will be using this equation here, where n is the amount remaining, which is often what we're solving for. And O, or n naught, is the original amount. And we're using 1/2 to the power of n, where n is the number of half-lives. Sometimes we'll use this n, and we'll say that n could also be the time divided by the time, or the half-life time. So we'll call this t, half-life. Okay, so if you said, well, there's 10 minutes and the half-life is every 5 minutes, well, 10 divided by 5, that little n value would be the answer of 2 in this case. Okay, so this is the other equation that we'll be using to solve for that lowercase n. So capital N is talking about, it could be a mass, kilograms, it could be number of nuclei, it could be BQ or becquerels, moles or percentages. So it depends on how we're solving this through. But just note that as the amount goes, as looking at this graph here, starting at 100% of something, when it jumps down to 50%, that means the daughter product went from 0 all the way up to 50. And then if we're looking at that, half of that time, number of half-lives, well, 2 would be, well, half of 50 is 25, then 12.5, and slowly you'll see that these numbers approach, but never actually reach the answer of 0. All right, so that's how the half-life works. And same thing for the daughter product. We then see a larger and larger amount, reaching that 100%, but never actually hitting that point. All right, let's try this. Krypton 89 decays by beta negative with a half-life of 3.19 minutes. Write the equation for beta decay and determine the relative percentage of parent and daughter isotopes present after 15 minutes. All right, so Krypton, so KR89, so that's going to be our number down here. Oops, never mind. The number up here, 89. Krypton, looking at my periodic table, just double check. We see that Krypton is atomic number 36. And if this undergoes a beta negative, we're going to say that's going to be our 0, -1 beta particle. We also know that there's also a neutrino that goes along with that, 0, 0, and it's actually the anti-neutrino. I'm going to do this in a slightly different order, but it really doesn't matter. And the daughter product would be 89 and 37. And if you look at element number 37, periodic table, we're jumping from krypton all the way up to rubidium, Rb.